All right, so today we're going over chapter 10, section 6, relationship in circles. So we have segments of chords. When two chords intersect at the interior of a circle, each chord is divided into two segments called segments of the chord. So this is kind of self-explanatory. This is a segment, this is a segment of that one chord, and then I'm going to do it in blue as well. This is a segment of this chord, and this is the other segment of this chord. So we have theorem 10.18, segments of a chord theorem. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So, important part right here, the segments per se are not congruent, but the products are congruent. So the products of the segments are congruent. So if we have segment AE times segment EB, it's going to be equal to segment EC times segment ED. So just as a quick example, if we say that each segment is, let's say, 12, we can do 3 times 4 and 6 times 2, and it's still going to equal 12. They're not going to be congruent, but they're going to have their products being congruent. So we have the secant segment. A secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of the secant segment that is outside the circle is called an external segment. So I want to point out the external segment is this, and then the tangent segment is the blue. What is the difference? The difference between a tangent segment, a secant segment or a tangent segment is that the secant passes through the circle. Okay, so it passes through the circle. We have the secant segment inside the circle, the external outside of the circle, but the difference between the tangent and the secant name would be that it passes through the circle or it doesn't pass through the circle. The tangent only touches the circle at one point. That is obviously another difference, but the key part is the words and if they cross through or not for the circle. So we have tangent segments. A tangent segment is a segment that is tangent to a circle at an endpoint. So you have the external segment, the secant segment, the tangent segment. So it's saying PS is tangent segment, again, does not cross through the circle, so yes. PR is a secant segment, yes it is, it crosses through the circle. And PQ is the external segment of PR. So this is all that it's saying is that for this long segment, this long secant segment, you can separate it into two for it to be the internal or the external segment. So far, we're only going to deal with, as of right now, only the external. Now we have theorem 10.19, which is segment of secant theorems. It states if two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equal the product of the lengths of the other secant segment and its external segment. So this whole thing is basically saying the whole segment times the external equals the whole segment times the external. Now, this is per section. So if this is the whole external and then this one is the other one, their products are going to be the same. Now keep in mind, the whole segment is this entire thing, and the external is just the outside part. Again, the whole segment is this, and the external is just this part. Again, it's just multiplying them, and they will be congruent. So they're saying Ln, this is the whole of the red, times Mn, the external of the red, it's going to equal Np, the whole of the blue, times On, which is the external of the blue. Here we have theorem 10.20, which is segments of a secant and a tangent theorem. So if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the length of the secant segment and its external segment equals the square of the length of the tangent segment. This is all it's saying is, again, we're going to do this entire segment. So the whole times the external is going to equal, again, JL being the whole, KL being the external, the segment for the tangent, but squared. So whatever this number is, we will square it, and that's going to equal the multiplication of the whole segment times the external segment of the other one. This is true only for secants, segments of secants and tangents. If it's secants with secants, it's whole times external in the last slide for both of them. And if it's secant and tangent, then it's the whole times the external segment for the secant. It's going to equal the tangent squared. So here we have example 1, A and B. For A and B, they want you to find x for both of them. Now, because it's the two chords, products of the segments, of course, congruency, that's a theorem we're going to use for the first one. I'm going to do 3 times x is going to equal 12 times 2. So that's going to be 3x is going to equal 24. I'll divide by 3 on both sides. And I'll get that x is equal to 8. Now, for B, we're using the tangent. It's going to equal this segment secant or secant segment theorem. So the way I'm going to do it is the tangent is the x. So I'm going to do x squared is going to equal 18 times 6. Just kidding. It's not 18 times 6. 18 is just the internal segment. It has to be the whole segment times the external. So it's going to be 18 plus 6. So that's going to be 24. So 24 times the external, which is 6. The whole is 24. So please make sure you guys don't make that same mistake I just did. It's the whole segment times the external, not the internal times external like it is for the chords. Good thing I caught it before we even started. So we get x squared is going to equal 144. We're going to take the square root on both sides. So we're going to get x is equal plus or minus the square root of 144, which is 12. Now, before you write that as your final answer, look at the figure. In this case, there's no way we can have a negative 12 as our answer because we can't have a negative amount for a line. So our final answer is actually just going to be positive 12. So for C and D, again, they want us just to find x. So I'm going to use the two secant segments. So remember, it's the whole times the external. So this entire thing is 12, and this entire thing is x plus 6. So I'm going to do x plus 6 times the external, which is 6, is going to equal 12 times the external, which is 4. I will go ahead and distribute the 6 and multiply the 12 and the 4. So I'm going to get 6x plus 36, and that's going to equal 48. I'll then go ahead and subtract 36 on both sides. So I get 6x is equal to 12. I'll divide both sides by 6. And I get my x to equal to 2. So this is our final answer for C. Now for D, we're going to use a tangent and secant. So again, I'm going to do 10 squared. It's going to equal the whole, which is going to be 2x plus x, times the external, which is x. Now I'm going to go ahead and simplify that 2x plus x into 3x times x. So that's going to simplify to 100, 3x squared. I'll go ahead and divide both sides by 3. So it'll give me 100 over 3 equals x squared. I will take the square root, and that's going to give me, I'm going to go up here, 10 over root 3 is going to equal x. Now it's going to be the plus or minus of that. Now I'm going to rationalize this, so it's going to become 10 root 3 over 3. And that's going to keep the x. Now in this case, remember to keep the positive only as your answer, because when we check it into here, we don't really want a negative value for our final answer for the actual segment. So make sure you keep it positive. All right, since there's no questions, guys, this is it for today's notes.